Good morning, everyone. Today we'll try to discuss on file organization in DBMS. So whenever a client is giving a data, the data is going to be written to your physical file system to be stored in permanently. To store this data, there is a process which is going to be held between from user to your server side. So then we'll try to trace out that, and we'll try to see what are the different kind of techniques which are involving in your file organization. So before entering into that, we'll try to see a simple representation. So this is how your architecture is going to be represented regularly. From your client, the user is going to be from a client. The client is going to store the data into your physical file system. So in between, there is a process is going to be happen. First, the data is going to be given to this instance. The instance will do all kind of validations, so like SQL query is coming in a proper way or not. After that, it will check through with some kind of buffer representations as a library cache and data dictionary cache. And after this, if the user wants to insert the data or to pull the information, first they need to contact a DBMS, and after this DBMS, the data will be pulled or to be inserted from your file system in a structured manner. So in this chapter, we'll try to see that how these components are going to be helpful for us to write the data. And whenever the user is giving an information, maybe it is a different kind of data. Maybe, for example, my record is consisting 10 KB information, first record, and second record is going to be 20 KB information. So these are not equivalent. So how this data is going to be written to your file system, we'll try to see them. So for example, why this topic is important means, in your file system, Oracle is always use 8 KB as a default size for your file system to store your data. If you are going for Hadoop big data related content, there should be you can expand your block size from 64 to 128 KB related length. So your data is huge, we need to use huge block representations. So this is how your things will be happen. So how these files are organized in your database, and as well as how your data is inserted into this file system, in what process they are going to see. And after that, what could be the importance for your data dictionary and as well as your DBMS. So we'll try to trace out them one after the other. First we'll go with file system, next we'll go with this remaining buffer representations. Right. So before there is a representation, we have files. So this file is nothing but a complete collection of records related information which has to be stored. So what do you mean by database means? In simple, a database is a collection of file system or collection of your files. So if you are having any kind of doubt, you can also go through your Oracle installation steps. There should be, you are having system DBF file and sysax files, and you have temporary DBF file, and as well as you are having undo TBF files for your database. If you are going to install your single database, there are several kind of files which are going to be represented. So in these files, so we are going to store our data. So in your table, it should be data is nothing but a record or your column representation. So obviously your data will not be sit in your column basis. The data is going to be represented in the record base. So a simple term, how this file organization is happening means, so there should be a database. The database is consisting multiple files, and each file you are going to store your data in the record manner. So records are going to be stored in the sequential order. Just you can create some kind of array, and one after the other it is going to be stored. And here how the data is going to be stored. For example, I have a file system called sysax. Now I have some kind of inserting element into employee table. So now the data is going to be 12 KB. So the data is going to be fixed and it should be stored. After that, even though the user is inserting 12 KB in data, then one more employee record will be inserted, and all the records which are coming into 12 KB related content. Maybe if I am randomly going and one after the other, and for example employee table inserted with a 12 KB and the department table is 8 KB and one more table is something else. So there is no fixed size representations and there is no fixed space to insert your data. It's completely user defined representations to store your data. It means what, based upon your requirement you should give the storage representation. For example, my priority is the employee table, so I create this employee table in some other file. So whenever the insertions are happening, the incomplete insertion will be happening into separate files. But coming to the basic level, how data will be stored means either it should be stored in the manner of your block size, or it should be this block size should be either fixed size or it should be variable length type. So we'll try to see that how this two things will be happening. And as per our notation, if the user is going with a fixed length, there is some kind of difficulties we have, and if you are going with a variable length, there is some kind of advantage we have. So how these files are going to store the records in terms of what fixed size or variable size. Now the first technique is fixed length records. So whenever you want to store your records, the record is going to be stored in the fixed length representation. It means what, for every insertion it is going to take some kind of fixed number of blocks, right? So for example, my first row is consisting some kind of 12 KB, but as per my representation it is going to be 4 KB, right? So whenever I am going to insert this data, so it is going to take 1, 2 and 3 blocks information was represented your record 1, and after this you are going to insert your next record to be placed into this particular file. So whenever the record is coming, that should be a fixed length, and you are going to store the data one after the other. And what is the problem with this fixed length means, for example, if I am having only 10K representation, for example my query is having 4K, so if I am having 10K block, so right, so just assume that, so my record is consisting 12 block, so 10th will be filled, and after that 2 bytes of memory will be 2 KB of memory will be given to the first block. So first block is got filled. So now the remaining space will not be used further to insert any kind of data. So the next insertion will be taken from the next block which is empty. So this is how your fixed length based record is going to be store your information. So what is the problem with this kind of approach? So there is a problem with your storage, because there is huge wastage will be happen, because your new insertion will be happen to the next of your empty space. So it should be happen from the new block. So whenever you are pulling the information will be pulled, but there is an empty space will be there. This is going to be not going to be an optimal representation for your data storage. So in order to overcome this kind of fixed length record representation, we have to go for your variable length based representations. So your data is continuously storing, and it is completely based upon the fixed length. But the problem is what, wastage is very high, and as well as your data retrieval takes too much time, because we need to skip this empty spaces now. So that is a biggest challenge in your fixed length based record storage. So instead of that, we'll go for variable length based, because our choice based upon your user interest data can be set. So we'll see how this is going to be happen. Before entering into that, there is some kind of advancement in fixed length record. So one is if, for example, just try to assume that if deletion is also biggest challenge for this. So if a deletion is happening in your complete table, so then what is going to be happen? How the things are going to be changed? So see this here, we have some kind of record representations. The data is going to be stored from 0 to 11th. Unexpectedly, some records were deleted. So the empty space is going to be always a challenge for us. So in this particular scenario, if there is any free spaces available, so there is a pointer which will be created as free list. So this is always tracking about your deleted records. When a new insertion is coming into the picture, and we are going to verify this free list, and the data is going to be inserted into your deleted record. So try to observe this next slide. So in this, for example, I have deleted some kind of record number 3 was deleted, and after some time the last new insertion whatever is there, that is going to be takes place into this third empty space. So here the thing is, if your record length is fixed, so then we can do this. If the record length is not fixed, so this is not going to be sit in the place of 3. So this is one more challenge we may have. If it is fixed with the length, so you can happily insert the data. If it is not going to be fit, there is one more challenge will be raised in your general representation. So how this free list maintains means, for example, the header will be generated on your table or a file, and it is going to always track about all the deleted representations. So for example, you see this, so this pointer header is pointing to the next reference and next reference, next reference. Like this, you are having all the options. So whenever a new deletion, any deletion is happening, and if you want to insert a new data, then by checking into free list, you can insert your data. So we'll try to go for variable length record representation. So it is completely your database is going to be store multiple record types of information. It's best suited to store this kind of information. So one after the other, your multiple records are coming from different kind of data tables. So then it is going to be most useful. So all these record types are going to be variable length based, because based upon your user information, we are going to allocate some kind of storage for your representation. To store this, we are going to maintain some kind of header, and this header consists some kind of details like this, and so it is always maintain some kind of pointer representation, and from the header, this pointing to the information actually where the data is going to be stored. See, this is my representation, and it is pointing to this 21 block. So there my information is going to be kept. And next one is this 26 is going to be my block number, and it is consisting some information about your user. So always we are going to maintain some kind of metadata, what the data is going to be stored in my detail. So why this is used means, this particular information will point to this actual information where it is going to be stored. So with this, we can optimize your information from where your data is going to be stored, how the data is going to be pulled. So with the help of this header, I can read the information which exists in your database. So how this variable length based is going to be managed, and what are the important factors we have, we'll see now. See, this is the basic funda for your variable length record representations. So for example, if you're having a file like this, right, this file is going to maintain your records from left to right side. So from one end, you're going to maintain some kind of your metadata. So this will exist like your header. So this treats like your header, and the header will consist the information of what is your free space, and where it is pointing, and all your metadata which are already stored in your record. So this is going to be free space. A new record is coming, and it should be inserted wherever the free slot is available, and this should not be based upon your fixed length, it should be variable length, and this information will point to this header. And here what is going to be happen whenever a deletion is happening, so automatically this pointer will remove that space. So after some kind of time, this records will be represented with some kind of refreshment in the database. All you are moving towards to the right side, and it will be shrink and it will be upgraded. So whenever new insertion will be happening, it will be expand, and if any deletions are happening, it is going to be shrink your storage space. So this is how an optimized representation for your variable length based representation, right? So this page is consisting an header and as well as your file system where it is going to be stored, and every detail will be maintained in the header, and it is similar to your CD drive related representation, but the most advantageous, it is not depending upon the user information. It's like fixed length is not going to be managed here. It is variable based length. Whatever the data you are giving, that should be stored into this particular file system. So whenever you are pulling information, the information will be captured from your pointers where it is existing. So this is how your variable length based records are going to be handled. So after that, we'll try to see, right? So there is some kind of file organization. So till this particular point, we were seeing how data will be stored into your file system. Now there is an option we have. We'll try